Bluetooth evolved over time, so we covered the basic settings, but then as you can see, there's Bluetooth 1.1, 1.2, etc. enhancing the standard with higher data rates, adaptive frequency hopping, I will come back to this to avoid interference. There's even support for this pairing, as I explained, using NFC, adding basically wireless LAN to have higher data rates. We could discuss this if this makes sense, that in the end the Bluetooth is suddenly something like a wireless LAN. There's some competition between these Wi-Fi and Bluetooth and whatever alliances and organizations. Bluetooth 4.0, that was a major step because since 2010, 13, 14, we have low energy, much faster connection setup. That's really a different type of standard. I will cover this in a second. And Bluetooth 5 comes with longer range, higher data rates, localization, and, well, park state doesn't exist anymore. Low energy. What is special about this? This is not the classical Bluetooth anymore. It's the same name. It's also called Bluetooth. It also operates at 2.4 gigahertz. There's also some frequency hopping, but it's not about the data rates, 1 megabit per second or optional 2 megabits per second. It's also not that much about special mesh networking, so it's possible now to perform mesh networks. Well, okay, thousands of devices. That really is different. But if you look at the MAC schemes, frequency division multiple access, we have now suddenly 40 channels, not 79 anymore. Different spacing, and we have specialized 3 channels for advertising. What this is, I will explain, and 37 channel purpose channels. There's also a polling scheme with certain predetermined intervals available. The interesting part is that now the physical channel is subdivided into what is called an event. We will learn a bit about advertising events, connection, periodic advertisement, etc. And then a quite interesting part is so-called direction finding for real-time locating systems. So using angle of arrival, angle of departure. Remember, we discussed MIMO using this for beam forming, but also for detecting where someone is. If you actually just check if you have several antennas and then the wavefront is approaching you from a signal, then first the signal is here at this antenna, and then some nanoseconds later at that antenna, and then depending on how you arrange the antennas, you can detect this shift in the phase and calculate the angle. Here, a picture of a chip that includes all of this, Bluetooth and Bluetooth Low Energy, but also Zigbee, standard I will cover briefly in another section. Okay, coming back to the physical layer. That's different from the classical Bluetooth. Bluetooth Low Energy has these channels, these 40 channels, but 3 of these 40, 37, 38, and 39 at certain frequencies, they are the so-called advertisement channels. These advertisement channels, they are used for primary advertisement for initial contact between devices. So there's no more synchronization to a hopping pattern. No more hopping for the initial access. So there are no slaves that have to synchronize to a master in this stage. I will come back to masters and slaves in a second. And then there are some more general purpose channels. So this is absolutely not compatible on this layer, the classical Bluetooth and the low energy. Sure, there are also many packet formats, and they are also completely different from the classical Bluetooth. So you have certain preambles, that's always important in radio. So a preamble, that's 101010, and then depending on the first bit of the address, or 010101, etc. That's for synchronization, gain control, that's very important, but also simple timing. So do we operate at 1 or at 2 megabits per second? Then there's an address, the PDU, a checksum, And then something interesting and new, the so-called constant tone extension. Predefined bit patterns, they are optional and they're used for this angle of arrival, angle of departure estimation. And this enables those devices to perform a 3D localization. So with the help of Bluetooth Low Energy, you can find devices in space, in 3D. So for example, in a supermarket, you will precisely find where the milk is, if the milk is Bluetooth Low Energy equipped. That's maybe not the best example, but if you have something expensive or whatever, you can locate it. Okay, so now why this low energy has certain advantages, like not only low power, but way faster reaction time when you transmit something. This is why you can use it for beacons, for example, smart beacons. Well, Bluetooth does not need to form a piconet to transmit data. A Bluetooth device with low energy does not have to synchronize to the hopping pattern, but it can communicate using a so-called advertising event. It's just a piece of time on the physical channel. So you start as an advertiser by sending the advertisement using one of the advertisement channels. We have 3 of them. You pick one of the channels and you simply send it. Then you have another device that acts as a scanner, and the scanner receives it and may make a request, whatever, and to you as the advertiser, and you can again answer. So that's the idea. So you just send an advertisement, and then you can set up a bidirectional communication. You can set up something like periodic broadcasts, isochronous streams, but you don't have to. So you can, if you want, just use, well, your advertisement channel, send the advertisement, and then you go to your next channel. If you start with advertisement channel K, then the next one is K plus 1. There are 3 channels, and then you just pick the next one. And then on this next channel, you can then exchange some data. Send advertisement, the scanners receive, and you can also then exchange a bit of data and can continue within a certain advertisement event. This could be very short. So that's ideal for quick exchange of data. You don't have to set up connections. You don't have to synchronize to some hopping. That's the basic idea. You can, if you want, set up also connections, the ACLs. Therefore, you use an advertising event. The advertiser sends the advertisement, and this time the role of the device is called initiator. So you see, the devices can have different roles. I will explain this on the next slide in more detail. So an initiator may listen for special advertising packets. Okay? And if the initiator receives such an advertising packet, that's a special packet, then this initiator may make a connection request on the same channel. Here. So there's a request sent back to the advertiser. If now the advertiser accepts the connection request, you don't have to, but if you accept the connection request, then the initiator becomes the master in the piconet and the advertiser the slave. So please remember, the advertiser sends an advertising packet saying, I want to set up a connection. And the initiator then says, okay, you can set up a connection, and then the initiator will become the master. And the original advertiser, the slave. And now we have again a master-slave setting. And now the master can send data to the slave can send data to the master, similar to the classical Bluetooth, but now, this time, we use only 37 frequencies, again for interference prevention, and so we hop through the channels, 37, and we can exclude some more channels if there's interference with the wireless LAN, for example. So it's again a pseudo-random pattern. Okay, that is the idea that we now use the original advertisement to set up connections, and then we have connection events. And while we stay on one connection event, we stay on the same channel. And the master determines when this connection event stops, and we go to the next connection event using the next channel. So there's a certain hopping pattern, but the master determines everything. So that's the idea. We can also use then this ACL connection and the master to establish isochronous connections, etc. Again, this sounds then a bit more complicated, but these are the basic settings. So how does it work? Let's have a look on this example. A device in Bluetooth Low Energy can have different roles. You can be a master, a slave, advertiser, initiator, scanner, etc. So, first example, piconets. The piconets here, although the name is the same, they are different from the classical Bluetooth. The piconets, they now, comprise different frequencies used. It's not determined by a same hopping pattern, but here in this example, we have A, device A as a master, B and C, they are slaves, but they use different frequencies. They all belong to the same piconet, so the term piconet is used here, but it's not the same piconet we had in the classical Bluetooth. So this is a piconet A, controlled by the master A, and the two slaves B and C, here in the role of slaves, not the same frequencies. A as a master, can also act as an initiator. That's group D, for example. Group D, that means D is a device that acts as an advertisement. Advertising, please, let's set up a connection. Then A has the role of an initiator and could, for example, add the device D to the piconet A. So D will then be a slave afterwards, but then using, again, a different frequency. So you do not share the frequencies here. So it's not a shared hopping as we have in the classical Bluetooth. Or there's another scenario, group C consists of C as an advertiser and E as a scanner. Advertising, scanning, that was this fast, quick exchange of just some data without the connection setup. So you see, the devices can have different roles in Bluetooth, low energy, depending on the application. Just exchanging some bytes, then you would not set up a connection. That's a beacon will just transmit some bytes and that's it. So we just advertise something. And then you have a scanner scanning for whatever's going on. So that's the idea. And we have 3 advertising channels, and you can use different advertising channels to avoid collisions. And if you do not know the advertisement channel, well, you have to check. There are only 3. So the advertisement will be somewhere. So if you look at the role of a device, the device can be in standby mode, but can be also in advertising mode, in scanning mode, initiating mode. That's what I showed you. and with advertising, initiating, we can set up a connection. There are some more states, asynchronous broadcasting, synchronization. So that's quite different from the states in a classical Bluetooth device. So coming to some questions, what are the major changes when going from Bluetooth basic rate, enhanced data rate to Bluetooth low energy? How do devices find each other? How does it work? And what are differences of BT basic rate, enhanced data rate piconets and BT low energy piconets? Why can the low energy devices react and transmit faster compared to the classical Bluetooth? And where can collisions happen during data transmission in Bluetooth low energy?